Welcome back, Swifters. This is Prof G. You are now champions of the while and repeat while loop, but we're going to introduce another loop, and we're going to take a little bit of a detour away from the You Are Awesome app for some Playground Loopiness, where we discuss the for loop, and you'll learn how to implement this in 3 ways, using closed ranges, half-open ranges, and by iterating through arrays. We'll discuss the backward method. We'll cover trickiness in Swift math. We'll warn you about dividing by ints, and we'll give you 3 ways to solve those problems using implicit declaration, explicit declaration, and type conversion. We'll cover the remainder operator, which looks like a percent sign, but its behavior is decidedly not. And we'll cover stride. So if you're ready for big learning, let's stride on over and get at it. Super Swifters, in the last class we got the lowdown on loops, specifically with respect to the while loop and the repeat loop. Now both of these loops are great when you don't know how many times you want to go through the loop condition. With the while loop, we might not go through the loop at all if our condition turns out to be false. The repeat loop will always go through the loop at least once. But sometimes you know how many times you want to go through a loop, like if you want to do a simple count to 10. Well, for that, the for loop is the loop to choose. And the best way to learn about it is to take it for a test drive. Let's head over to the playground. So we're going to open up a new playground. So let's do File, New Playground. And this will be a blank playground. And I'll save mine right to the desktop. And I'll call it For Loops. And make this full screen. So this is how we write a for loop. We start with for, then we give it a named value that we're going to iterate over. This is the value that we're going to use to count. So we could call it x, or index, or Nicolas Cage. Why don't we just call it count? And then we say in, and then we give it a range. And we've seen ranges before when we worked on random numbers. So saying 0, ... 10 means start at 0 and go all the way through 10. Then I'll open my curlies, Xcode closes the curlies, and I can put any statements that I want to continue to repeat right in the middle. So I'm going to say print, and then in parentheses, count. Now what this is going to do is it's actually going to go through the loop 11 times. So the first time count is going to be 0. The next time count is 1, all the way up to the 11th time when count is 10. Now we can also option click on count, and we can see that it's an int because the numbers in the range are ints. And we also see, because the word is let here, that it's a constant. And that means it can't be changed inside of the curlies. In fact, what's happening in this loop is the range will create a new count each time it goes through. The first time count is 0, the second time count is 1, the 11th time count is 10. Once we're done executing the loop, count goes away and doesn't exist outside the curlies. So now Shift-Enter to run this loop. And now if we take a look down in the console, we can see the numbers printed out from 0 to 10. Nice work. And so now let's have a series of challenges, and we'll apply our knowledge of the for loop to see if we can use it in different contexts. And first, let's use it to see if we can go through the elements of an array and print them out. So we'll call this the Tubbys challenge. And we'll create a variable Tubbys, and inside of that, there's Tinky Winky, Dipsy, Lala, and Po. I want you to go through the Tubbys array and print out a Tubby on every line. And if you get stuck, think about how would you access each element in the array, and can you create a range to go through all of those elements? Pause, give it a shot, and resume. Let's see how you did. So we start off the for loop with 4, and then we can give the count of the numbers any name we want. We could call it count again, index. I'm going to call mine Tubby number. And I'm going to say in and 0, ... 3, because we've got 4 elements. Remember, we're 0 indexed, 0, 1, 2, 3. Open curly, close curly. And inside those curlies, we got print, and then in parentheses, Tubbys, which is the name of the array, bracket, and then Tubby number, which are those numbers 0, 1, 2, 3. Shift-Enter, looking good. But now our code should be a little bit better than it is, because we put in a literal range 0 to 3. But what if somebody else joins the Tubbys, like Larry David? So we added him to the end of the Tubbys array. If we do Shift-Enter right now, Larry David still isn't in the Tubbys. Now we're going to assume there's always going to be one Tubby, but if we want to go through all the Tubbys, instead of putting that literal 3 in the end, you know what to do. We can just say Tubbys.count -1. Now Shift-Enter, and Larry David is recognized as one of the Tubbys. He prints out in the end. Now the range we just typed in here, I'll put in a comment and say this is a closed range. And a closed range is written as the start number ... and then the end number. Now we'll also print the empty string, and this is just going to give me a line feed down below to separate my results printing in the console. Then I'll highlight my closed range code, copy it, paste it down below, change closed range to half-open range, and this is how you write a half-open range. Instead of ... it's ... less than symbol, and that means it'll go up to, but it will never reach what the last value is in our half-open range. And since we're never going to reach this value, we want to make it Tubbys.count instead of Tubbys.count minus 1. 0, Tubbys.count minus 1 is the closed range. It starts at 0, goes all the way up to and through Tubbys.count minus 1. The half-open range is 0, less than symbol, Tubbys.count. That goes up to, but never reaches Tubbys.count. Since that's an integer, it stops at Tubbys.count minus 1. Both of them do the exact same thing. Shift-Enter, it runs. We see the results of the half-open range the same as the closed range. Know them both, you'll see them both. And I'm going to go up in the empty string here. I'll type in half-open range, and I'll show you another trick. Just before the H, after the first open double quotes, I'm going to do /n, and that's what's called an escape character. It's going to give me a line feed, as if I were to press return. There are other escape characters too. They'll be in the reference in your online textbook. /n for line feed is the one you're going to use the most. I'll also put a print statement that says closed range up top. And then down below here, I'm going to say print /n, iterate through an array. Now what this means is we can use a for loop to go through an array, and we don't even have to write the range. I'll show you how. We say for, then we give a name of a value that's going to hold the elements in the array one by one as we go through them, and we'll say in, and then the name of the array. So for Tubby and Tubbys is going to go through the array Tubbys, every single element one at a time, starting at element 0, that's what Tubby will be the first time it goes through, all the way up until element Tubbys.count minus 1, which is the last element. Once we've looped through the whole array, we're done with the loop, we continue down below. We'll say print Tubby in between the curlies, Shift-Enter, and we get the results iterate through an array just like the other ones above them. What's different this time? Well, if we Option-click to take a look at the type of these values, we can see. Instead of using a range based on 2 integers and working with an integer, we simply put in the name of the array and we work with elements of the array. That means Tubby number is an int and Tubby is a string. Nice! And now I'm going to type in a new line in here, print average challenge with my /n escaped character in the beginning. And what I want you to do is I want you to create an array named quizzes, and it should contain the values 72, 81, 89, 95, and 92. I want you to use a for loop to calculate the average of all of the elements in quizzes, and then print the average after you've gone through the loop and performed the calculation. Need any hints? Don't pause yet then. Think about it. How do you average? What are you totaling up? What are you dividing? Check your work. Is your answer what you expected? And if not, why not? And for a bonus, use all 3 for loop methods, the closed range, the half-open range, and iterating through the quizzes array. Pause, give it a shot, and resume. Let's take a look. So let's create that quizzes array. Var quizzes equals bracket 72, 81, 89, 95, 92, close bracket. So I'm going to start with the closed range option. I'm going to say for, I'll give it a name. Quiz number is a good name. In 0, closed range, quizzes.count minus 1, open and close curlies. And then it's the basic math. How do you get an average of numbers? You total up all the numbers, and then you divide them by the number of numbers that you're averaging. How do we get a total value? Start with 0. Each time you go through the loop, add that element to your total. And when we use a range, we're going through numbers. So the way we find the element is the name of the array, bracket, the element's index value. So how is that expressed here? We can say total to hold our total equals total plus quizzes, bracket quiz number, close bracket. And what we didn't do yet is we haven't declared total. Just before the loop, we'll say var, total equals 0. And now we're ready to print our total line. I'm going to print a few values in here because the way that I've set this up, I have an error. And I tried to hint at this in the hints. Maybe you've already noticed it and hopefully you haven't committed this error, but let's see. So I'm going to say print total equals string interpolation total, comma quiz count equals string interpolation quiz count, comma average equals string interpolation total / for divide, quizzes.count. Then close my parentheses for the string interp, close the double quotes, close the print statement, and you see that I perform my math right inside the string interpolation, which is totally fine. Shift enter, and I get total is 429, quizzes.count is 5, and average is 85? Wait a second. 85 isn't 429 divided by 5. I can tell right away those numbers don't go in even, so there's a decimal there. Let me hop over to Google Sheets. What should this number be if I average it in here? 85.8. Where did my 0.8 go? So you might have guessed it's probably got something to do with types, and you would be right. Let's option click on total. We see that's an int. What if we option click on quizzes? It's an array of ints. And quizzes.count, that's an int too. So an int divided by an int is going to give an int. It doesn't have any decimal places. What does Swift do with the decimal places? It just throws them out. That's how we end up with 85. So here's another challenge. Fix this so that you get the correct average value. And if you did get the correct average value in the first try, outstanding work. You can fast forward to the next bit. I'll show a bunch of ways we could tackle the solution. So why don't you pause, give it a shot, and resume. Let's take a look. So dividing an int by an int just gives us another int, and we want to make sure that this is a double. One thing we can do is we can type convert total, and we can type convert quizzes.count. That would give us a double divided by a double, which is a double. So how do we do that? Right in front of total, we just put the word double, then make sure total is enclosed in brackets. Right before quizzes.count, we put the word double, make sure that's enclosed in brackets. Shift enter, and we get 85.8. Nice. Mission accomplished. But we also wanted to make sure that we could do the Halfopen range and iterate on the array too. So I'm going to highlight most of my code up here. I'm going to reuse quizzes and I'm going to reuse total. So I'm not going to declare those variables again. I will reset total to 0 before every loop so that I don't add my last total to my next total. I'm going to first put in a print statement that says Halfopen range. Paste this in. I've got to say total equals 0 here. So that's going to reset my total value to 0, which I want to do, but I'm not going to redeclare them. Now the Halfopen range is going to go up to quizzes.count, but never reach it, so I can get rid of the -1. And the Halfopen range is not ... it's ... less than sign. And now that I've done Halfopen range, I'm going to do another print statement down here to show where I'm doing iterate through array. I'll make sure that I put my escape character /n before Halfopen range. I'll do a /n before iterate. I suppose those are really backslashes. I should say \n. And I'll paste in my original values, and I'm going to change quiz number to quiz. That's going to hold the element of the quizzes array. I don't need a range. I'm just going to put in the quizzes array here. And remember, this goes through every element in quizzes, puts them one by one in quiz, and so I can say total equals total plus and just quiz. Now I don't have to change anything in my print statement. Total is going to be the value I want, quizzes.count. But if I shift enter, I see that I got the wrong value here because I didn't reset total to 0. So let's go do that. Shift enter again, and now all three of these give me the exact same result. First one's a closed range, second one's a Halfopen range, third is iterating through the array. Know how to do all three. And now for a slight detour from loops, we're going to do some type math. And we're going to find out some of the strange things that can happen in Swift when we do type math. And we'll also learn about the remainder function. So I'll say let numerator equal 17. Let denominator equals 2. I'll do print numerator / denominator equals, and then in string interpolation, numerator divided by denominator. Shift enter. And under type math in the console, it says this result is 8. Because they're both ints. 2 goes into 17 8 times, so that means 16. There is a remainder, but in Swift, an int divided by an int gives you an int, and in Swift, ints don't get decimal points, so the remainder's thrown away, and just the whole number remains. And just to show this, what I'll do is I'll create a new constant result that's equal to numerator divided by denominator, and I'll replace in string interpolation here with the word result. Shift enter gives me the same value, but if I option click on top of result, I can see, yep, this int divided by an int is giving me an int. And I'll put some comments in here that says with ints, unexpected result, and I'll just do /8 underneath there to show what the result was. But then I'll cordon off in a print section here that says implicit declaration. We'll also show explicit declaration and type conversion, so we have all these in our notes. So I'm going to highlight this unexpected result code, copy it, command / to comment it out, paste it down below, and modify it. Now, if I want to implicitly declare numerator and denominator as doubles, I could just put a 0.0 after it. That 0.0 is a decimal point. Swift says, I'm calling that a double. Shift return, 8.5, problem solved. And if we option click on numerator, we see, yep, these two values that we implicitly declared are both doubles. Let's take a look at result, option click. That bad boy is a double as well. That is implicit declaration. Now let's do the print statement for explicit declaration. We'll highlight the code that just worked, copy it with a command C. We'll command / to comment it out, paste it below the print statement. I'll get rid of this extra print statement, and here what I'm going to do is I'm actually going to get rid of the decimal points so that I'm not implicitly declaring these as doubles, but I'm going to explicitly declare them by adding colon double, which is the type, right after the name of the value, numerator and denominator. I'll keep the result the way it is, so that's still implicitly declared. Let's do shift return, and it works. Option click on top of result, we can verify that's a double, yep. And I'll once again highlight this code, copy it, Command / to comment it out. I'll put in the comment for 8.5 just as a reminder that this worked. Paste this down below, and this is going to be the example using type conversion. And remember, type conversion wraps a value or an expression in parentheses and precedes that by the name of the type it's supposed to convert it to. So it doesn't change anything in the original expression, a variable or constant. It just takes the data out and converts it from one type to the other type. So to show this works, I'm going to reset the numerator and denominator back to ints by getting rid of the explicit declaration of double on both of these. And to do type conversion, I need to do type conversion on numerator and denominator separately before performing the math. If I do the type conversion with numerator / denominator inside, I'm going to turn an int to a double, but by that point, that int has already thrown away any remainder or decimal point value. Shift enter, it works great. Numerator is an int, denominator is an int, but result is a double. Now our type math detour isn't quite over. I want to introduce the remainder operator. It's the % symbol. In some programming languages it's called modulo, but Swift calls it remainder. And you use it in a math expression just like you would use the / for divide or the asterisk for multiply. But what the remainder operator does is, not surprisingly, it gives you the remainder, or what's left over after dividing one value into another value. So let's try it out. First, I'm going to copy the code above, I'm going to comment it out, I'm going to paste the code below, and just make some modifications. So I still want to work with two integers, and I'm going to say print numerator / denominator equals numerator / denominator, but below that I'm going to say print numerator remainder operator denominator equals numerator remainder operator denominator. And the remainder operator is the %, so shift return and check the result. And so we get numerator divided by denominator because it's an int of 17 divided by 2. Well, 2 goes into 17 8 times. That'll give us 16. It doesn't evenly divide into 17, so there's a remainder. That one that's left over, that's the remainder. That's what you get by using the remainder operator. So let's try some more values just to see. I'm going to change denominator to 3. Shift return, we get numerator divided by denominator is 5. How come? Well, if you take 5 multiplied by 3, that's 15. What's left over to get to 17? That's 2, and that's what we get from the remainder operator. Change numerator to 16, you get 5 and 1. Change numerator to 18, you get 6 and 0. How come 0? Because 3 goes into 18 6 times, with 0 left over as a remainder. Let's see if you know how to use the remainder operator. Here is the is-odd challenge. So what we're going to do is we're going to create a value that will call value, and your job is to write code that will say if value is even or value is odd. Pause, give it a shot, and resume. Well, we know value is even if value remainder 2 is 0. That means there's nothing left over if we divide 2 into value. So we'll say if value, %, meaning remainder, 2 equals 0. And then in the curly braces, we'll simply say print string interpolation value. Then after the string interpolation is even. Then in the else condition, same thing, except we're going to say print value is odd. Shift return, 17 is odd. Let's change value to something even, but a big even. How about 1, 3, 5, 7, 9, 2? Shift enter. 1, 3, 5, 7, 2 is even. Nice work. Time for another challenge to make sure that you know how to use remainder. We're going to have the Winter Olympic Year Challenge, and you'll have two constants. One is the year you want to check to see if it's a Winter Olympic year, and you're going to test that against the last year where there was a Winter Olympics, which is 2018. If it is a Winter Olympic year, you should print out the year will be a Winter Olympic year. If it's not, you should print out year will not be a Winter Olympic year. And as a bonus, print out you'll have to wait, and however many years you have to wait, more years. Pause. And give it a shot. And we resume. And the code is very similar to what we did with our is-odd challenge. We're going to say if year minus Winter Olympic year, so that's going to find the difference between the current year and the other year. And we know it's a Winter Olympic year if that value, that difference, can be divided by 4 evenly. Now we just test that by taking that value, using the remainder operator 4, and if that equals 0, it divides evenly by 4, it's a Winter Olympic year. Else, Year will not be a Winter Olympic year. Now how do we go ahead and do the calculation of how many more years? Well, this remainder value tells us how many years over an Olympic year we are. So 2022 is an Olympic year, the remainder value is 0. 2023, the remainder is 1. That means we've got 3 years to wait. 2025, the remainder is 3, so we've only got 1 year to wait. So we just take 4 and subtract it by this remainder value. And we'll test it out. 2022 is a Winter Olympic year. 2020 is not a Winter Olympic year. You'll have to wait 2 years. 2023 will not be a Winter Olympic year. You'll have to wait 3 years. Nice work. And if you didn't get that, why don't you go back and look at the code, think about it step by step, line by line. You can even use a separate piece of paper as a scratch pad as you trace the code and change the variables. You'll definitely want to get this down. All right, now back to loops. Next challenge is the like Swift challenge. What we're going to do is we're going to take a variable how much liked, and we're going to use that to find out how much you really like Swift. If how much liked is 1, then print out I really like Swift. If how much liked is 3, print out I really, really, really like Swift. We assume whoever uses this will, at a minimum, at least really like Swift, and maybe more. Why don't you pause, give it a shot, and resume. So we know we're going to say I like Swift, and we know we want to build up a phrase that has as many of the word really in there as our value how much liked. So why don't we go ahead and create like phrase as an empty string. And then we'll loop through how much liked. So we'll say for like count in 1 ... how much liked. Inside the curly, we'll say like phrase equals like phrase plus, and then the literal string in quotes, space really. That's how we're going to build up our really, really, really phrase. And then we'll say print I, string interpolation, our built up value like phrase inside the string interpolation. And then we finish the rest of the phrase inside the double quotes with like Swift. And notice in our string, the capital I and our string interpolation are right next to each other because we add a space in front of the reallys. Shift return to run. I really, really, really like Swift too. Let's change how much like to 1. Shift return says, I really like Swift. Change how much like to 0. Can't imagine somebody not really liking Swift. And our code crashes. How come? Well, we can't form a range where our starting value is greater than our ending value. The actual error down here is fatal error, can't form a range from upper bound less than lower bound. Well, why don't we set how much liked to 3 for now, and we'll leave fixing this, as well as adding commas in between the reallys, to one of the exercises below the reference in this section of the text. Now, there might be some situations where you actually want to start at a higher number and go to a lower number, like if you do a countdown. So let's learn how to do this. We'll create a section called print \n countdown, and we'll put in what we know won't work. For count in 10 ... 0, print count. We get that same error, can't form range with upper bound less than lower bound, but here's how we can fix it. So if we go back to 0 ... 10, our original range that we know works, enclose this in parentheses, then we can use a method .reversed with open and close parentheses, and this will reverse the values that are inside of the range. Now notice the exact text describing in here. It says returns an array containing the elements of this sequence in reversed order. That means the range 0 ... 10 will become an array of ints from 10 to 0, and that's what we'll push through count. You can use this on an array too if you wanted to easily put the values in reversed order. Now let's shift enter, and we can help Elon Musk with a countdown from 10 to 0 to blast off the rockets. So now we know how to count backwards. How can we count forward by larger increments? Say if we wanted to count by 4s. Well, we can use a command called stride. So let's create a new section, print \n stride. I'll put a comment in here that says what we're about to do. Count by 4s to list the next few Olympic years, starting with 2020. And this is how we write the command. For year in, and then type stride. And look what code completion describes. First, we've got these two commands, one that has 3 parameters from, through, and by, and another one that has the parameters from, to, and by. We're going to use the one that says through, and it says returns a sequence from starting value and possibly including the end value, stepping by a specific amount. Well, what's this possibly about? What this means is we start at the from value, we go through the end value, and we step forward by whatever amount is inside of by. If striding through that value happens to land on the value in through, then we'll show through. If not, we'll show the value before it. That's as opposed to what we see down below, where instead of saying from through, we say from to. From to means we'll go up to the value in to, but we'll never reach that. The best way to understand this is with some examples. So let's give it a try. So I'll press return to accept the stride I've highlighted here, and that gives me stride from, I'll put in 2020, through, which means go up to this value, which is 2050, and by 4, because we want to go up by Olympic years. And then in the curlies, I'll just say print year, I'll do a shift return, and let's take a look at our results. And we see the last one is 2048. Hey, I'm supposed to go through 2050. How come I'm not showing 2050? Well, that's because 2050 isn't divisible by 4. There's 2 left over as a remainder. What's the last value through 50 that's perfectly divisible by 4? The value that we stride by? That's 2048. So all right, for our notes, I'm going to copy this code, comment it out with command /, paste it down below, change the through value from 2050 to 2048, shift return, and sure enough, we see it goes up through 2048. That's perfectly divisible, so that's why we stop there. Now let's comment out this code and try the to parameter. Paste down below, and I'm going to change through to 2, T-O, and I'm going to go up to 2048. Now this will go up to, but it'll never reach 2048. So if I shift return here, I see we stop at 2044, even though 2048 is evenly divisible because I used 2 instead of through, we never reach 2048. And you can put a reminder comment in here for your notes, something like 2 means go up to, but don't include this value, sort of like a half-open range. So you might wonder, hey, can I go backwards using stride? Yes, you can. So let's put in a sprint statement that says backward stride and give you an example. This time, let's count backwards and see all of the Olympics from 2020 all the way back to whatever an early Olympic year is. So why don't we create a constant let early Olympic year equals 1982 for starters, and we'll say 4 year in stride from. Now we're going to start at the Olympic year 2020, we're going to go through whatever early Olympic year is, and we're going to stride by -4. And then we'll print the year. It is totally okay to do this with stride. So even though in a range, you've got to have a small number, ... a larger number, here you can start from a larger number and go through a smaller number or up to a smaller number, as long as you've got a negative that you're striding by. And I'll print year in the curlies. So let's shift return, see what we get. And we stop at the Olympic year 1984. We could have gone up to 1982, but 1982 was not an Olympic year, so that's why it's not being shown. And okay, now that we know how to use stride, let's go ahead and take this challenge. And you could solve it in a bunch of different ways, but why don't we use stride? And we'll use a print statement to call this the Make Teams Challenge. And what we're going to use is an array, var students equals, and inside we've got the names of the students, Harry, Hermione, Ron, Ginny, Luna, and Victor. Your challenge, create 2 teams, Team 1 and Team 2, and assign every other student to either Team 1 or Team 2. Give it a shot with a pause, and resume. Again, lots of different ways to do this. Here's just one. Since I'm putting the students into 2 teams, I'm going to create 2 arrays, a Team 1 and Team 2 array. They're both string arrays. And since they start out empty, I need to declare that it's a string array. So I'll say var Team 1 colon, and then in brackets string to say, hey, this is a string array, and then equal empty brackets to say it starts out empty. I'll do the same with Team 2. Now I'm going to loop through the students, and I'm going to use a stride. So I'll say 4, index will be the value that I stride through. In stride, I'm going to select from to by. My from value will be 0, the first element in the array. My last element will be student.count. If I did through, I'd do students.count -1. And I'll do this by 2, so I skip every other student. Now inside the curlies, I'm going to add a student to Team 1. So I'll say team1.append, and then in parentheses, students, bracket, index, close bracket, close paren. And then we'll write some code that works for this example, but we'll modify it to make it better. So in the second line, we say team2.append, students, index +1. So we get that next student, and we put them in Team 2. Now I'll shift enter. You know what? Instead of going to the results pane, we'll just print out Team 1 equal Team 1 string interpolation, Team 2 equals Team 2 string interpolation. Shift return. This looks great. But I said our code was a little less perfect. Let's go up here and add Draco to the mix. Now this means our array has an odd number. If we go ahead and shift return, oh, Draco ruins everything. We get a fatal error, index out of range. How come? Well, when we add Draco, he's the last student. He gets successfully appended to Team 1, but then we try to head down to Team 2 and append students index +1. At this point, there is no index +1. We get a fatal error, index out of range. So why don't we set the rule where we'll allow uneven teams, but we check to see if there can be somebody that we can put on team number 2. If not, we'll just skip it. And we can do this with an if statement. Lots of ways to write this, but why don't we write if index +1 is less than students.count -1, meaning make sure that we're not going past the very last element in the array, and if so, we can cut out what we did below, put it in the curlies so that we append that student to team 2. So shift return to run, we get our 2 teams, nothing crashes, our first team has 4 students, our second team has 3 students. Excellent work. Let's start playing Quidditch. All right, Loop Legends. So now you are masters of the for loop because we covered for loops with closed ranges, half open ranges, and iterating through arrays. You learned how to use the backwards method. You learned how to deal with trickiness and swift math, specifically when we divide by integers. We gave 3 solutions using implicit declaration, explicit declaration, and type conversion. You learned about the remainder operator. Some call it modulo. It looks like a percentage sign. It's not. And you learned how to handle stride. You accepted the throwdown of multiple challenges and succeeded. Congratulations, Swifter, and keep at it.